So I'm just going to give a quick overview of the 2021 fire season as we see from satellite and you see via the NAFI website. And I'll give a quick update of some new features and things we're planning on NAFI for 2022. So I might start with an animation of the fire year, 2021 fire year. So this is an animation of all the hotspots throughout the year. And we can see going into April, we're getting those good early dry season burns through the Kimberley, moving to the western top end. And as we head into June, over into Arnhem Land and the Cape. And then as we get into sort of around mid-August, we started to see a few fires sort of ticking on, particularly in Tiwi and over in the Dampier Peninsula, and the beginning of a few fires in the southern rangelands. These sort of picked up going into October and November in particular. So you can see some particularly large fires through the Tanami, the Gulf, and the Southern Cape. So another big burning year, 2021. Now, if we look at that same fires with the actual NAFI mapping, we get a sort of more sort of nuanced or detailed view of the mapping. And we can see overall it wasn't such a bad year. Some really good burning, once again through Kimberley, most of the top end and across the Cape, but a lot of big fires in that southern rangelands area. If we can look back a few years at the early and late dry season breakdown of the amount burnt, we go back to 2018, I think 17 as well. They were pretty big years, some dry years, some really tough fire management years. Got some good results in 2019, and last year was really some of the best practice fire management year, really good conditions. Going to this year, I mean, the early dry season burning has stayed pretty steady, but some larger sort of fires later in the year. Just have a look at what that looks like on the map imagery. 2019, not too bad. 2020, that really good year. Then 2021 really sort of picked up some of those late dry season in that sort of lower rainfall zone. Now, if we just look at the higher rainfall area above 1,000 mils, this is where most of the carbon projects are occurring and probably the majority of the sort of proactive fire management. And we compare the early and late dry season fire extent, we see a very similar amount of early dry season burning. That's remaining pretty steady, and a slight uptick in the late dry season, but not a huge amount. Now, if we look at the same thing by jurisdiction, we can see that almost 3/4 of that northern rainfall zone in North Kimberley didn't burn at all. Only 15% burnt later in the year. The top end, around 60% didn't burn at all, and a fairly low proportion late dry season, 12%. In the Cape, certainly got a few of those larger fires that often occur in the Southern Cape late in the year, 20%, but still very large proportion didn't burn at all, which is a good outcome. We compare this back to the last year, and we see quite similar ratios throughout the year. So not a huge amount of change 2020 to 2021, just slightly rougher, tougher conditions last year. And that's probably due to 2020 being such a good year. There's a little bit more fuel around, but overall well managed. So I just want to quickly run through some updates with NAFI. So colleagues working on a complete sort of design update on the NAFI interface. The first thing you may have already noticed is a quick link button in the top right of the NAFI interface, which allows you simple access to the current hotspots and some of the high resolution burn area mapping we're now providing. We're sort of looking to expand some of that new functionality in this new interface. Just showing a prototype of that now. It's a work in progress, but it should be a much more streamlined and easy access to a lot of the NAFI functionality in this new design. So hopefully we'll have a version of this up in the first half of this year, in the next couple of months. The old version of NAFI will still be available for a while for people who don't like change, but yeah, this new version should be a real advancement. We're also looking at how we can provide some new data and new reporting tools. Many of you have probably seen the Savannah metrics, the Smurf interface. We're sort of looking at ways we can integrate that more into the NAFI interface and provide much more detailed metrics on certain properties, land tenure types, and this may end up being a sort of subscription or a fee for service where we provide that more detailed information. We're also exploring new fire metrics. This one I've been working on for a number of years, originally developed by Ben Lewis, who works with the Jarwin mob, and we're looking at fire edges, so where fires have stopped historically through the landscape using those long historic NAFI-derived data sets. So if we just sort of zoom in for this example from the Cape, it really pulls out where those features that are potentially pulling up fires. So that's just an example of the sort of data that we might be adding to NAFI to assist managers thinking about how they need to put fire into the landscape. We're also continuing to work on NAFI-related training development content. So one of the first things we'll be developing training around the new interface and potentially a micro-credentialed module that we can deliver remotely to everybody who needs to develop those skills using NAFI. Will probably be linked to this savannahfiremapping.com site, worth having a look there. I've already developed some fire management QGIS training, but we're also looking to develop a whole range of spatial information for fire management training content up there. Just an update on the mobile app. Some of you might have noticed that it's been running a little bit differently. What we've done is reduce the zoom level at which those hotspots transition from a heat map to a very clear hotspot, and that slows things down a little bit, but we thought it was important that people are able to sort of see that hotspot resolution at a much higher level. We'll be continuing to request feedback on the mobile app, and as funding becomes available, wanting to continue to add features to that. And finally, the funding issue around NAFI. So we've been talking to the National Recovery and Resilience Agency over the last few months, and they've earmarked 3 years of funding for NAFI going forwards. We're just waiting for ministerial sign-off on that, and that will give us a bit more security, which will be excellent for being able to further develop some of these tools for assisting all the folks who are working on the ground out there. And thank you very much. I'll pass it on to my Bureau of Meteorology colleagues.
All right, well, I'll start by just reflecting on where we are in terms of climate drivers, and that means the broad scale influences on our weather. And if we look at the last 5 years, you can see that we've transitioned from conditions which are more typical of El Nino in Australian region, which is the influence from the Pacific Ocean that causes droughts and drier conditions over much of Australia, into La Nina conditions on the past 2 wet seasons. So those wet seasons that we've just experienced have been strongly influenced by La Nina, which causes above average sea surface temperatures around Northern Australia and cooler temperatures in the Central Pacific. So what we end up with is an overall increase in rainfall producing weather systems around Northern Australia. So we've had the benefit of that over the last 2 wet seasons. And also another influence is the Indian Ocean dipole, which is the influence of the sea temperatures in the Indian Ocean on the Australian region. And that turned negative in the late dry season last year and extended right through towards the end of the year, really. And that produces wetter conditions in the western parts of the continent. I'll show you in a minute just a diagram that represents that. But the other factors we need to bear in mind are that sea surface temperatures around Northern Australia have been above average. And this has a strong influence on temperatures over the Australian continent, and also the rainfall production from the tropical seas surrounding Northern Australia. And of course, all this fits into the sort of overall global warming, where we're seeing an increase in temperature over Australia, about 1.5 degrees in the last 100 years or so. And this has caused an increase in rainfall over the tropics, and also a greater proportion of high intensity rainfall events, so the potential for flood producing rains. And this has been observed pretty much worldwide, this sort of trend. Just quickly, I'll overview of the La Nina influence. You can see that the diagram on the left here shows stronger trade winds moving across the Pacific towards Australia, and that causes more storm activity in the maritime continent to the north of Australia, and an increased chance of rain over northern Australia and eastern Australia. And we've seen that influence quite strongly during the past 2 wet seasons. And as I mentioned, the Indian Ocean dipole, which kicked in spring last year, and you can see that that has a similar impact, except from the Indian Ocean. So westerly winds are stronger than usual, bringing moisture into the maritime continent northwest of Australia, and warmer sea temperatures in that area increase the chance of rain across Western Australia and into southeastern Australia as well. So in Northern Australia, we've had the benefit of both of these influences during the last 12 months. And if we look back to the wet season before last, as has been mentioned already, that they were pretty good wet seasons overall, but temperatures also were above average. So the charts I'm showing you here are on the left-hand side. They reflect the rainfall decile range, so how much above average or below average the rainfall has been. So the blue shades indicate above average rainfall, the red shades below. So you can see some parts of Queensland missed out, but the tropics overall, if you average the entire wet season 2021, were above average. In the temperature area, the minimum temperatures were very much above average through much of Queensland and the NT in the tropics, less so in the Kimberley. And I think that's due to increased cloudiness in that area and a number of incursions of tropical humidity into central Australia also would have caused temperatures to be slightly lower than average in that period. If we look at last dry season, we see a different pattern entirely. From May to September, the average is the rainfall was below average over much of northern Australia and extending right through Western Australia and down into central Australia as well. But the key signature of this season was, the last dry season that is, was very warm temperatures. And so this is shown in these maximum temperature deciles, which are in the middle panel here. The orange shades indicate very much above average, and even highest on record temperatures around the top end of the NT and right across parts of Cape York and into the Kimberley. Here in Darwin, we total up the number of days over 35, and we noticed in this dry season, days over 35 occurring on every month in the dry season, which really is a reflection of how much warmer than previous seasons 2021 was. The impact on minimum temperatures was less, but there were very much above average minimum temperatures across Cape York Peninsula and parts of the top end during the dry season. And if we look at the temperatures, there were some months which were particularly record-breaking, and July stands out, especially in the Kimberley and top end, where we had quite a few records broken, not only for individual days, but for the overall month as well. But as I mentioned, many parts of the tropics were overall drier than average, with the odd wet month thrown in. So autumn and rainfall was above average in the Kimberley, but still drier in the dry season. And June was a wetter than average month in the top end. So despite there being a couple of rain events and wetter months, the overall impact was a drier than average dry season last year. Now, if we move on to looking at the current wet season to date, and as I mentioned, there was an overlap of 2 influences here, the La Nina and the negative Indian Ocean dipole. So they both contribute to above average rainfall across the Australian continent. And also some anomalies with the position of the subtropical ridge to the south allowed more rainfall across southeastern Australia as well. So those blue shades really show very much above average rainfall over much of central Australia and above average through much of the tropics as well. But the above average temperature signal continues right through this wet season as well. So again, the period from October through to January, we're seeing above average maximum temperatures and very much above average minimum temperatures around northern Australia. And this is contributed to partly by the warmer sea temperatures around the continent, which feed in moisture and warmer air overnight, sort of preventing the usual cooling off, especially in coastal areas. So with that in mind, let's have a look at what's coming up. And just returning to those climate influences, the La Nina is forecast to continue to be an influence through until autumn. So possibly for us in the north through until April at least. And the Indian Ocean dipole has little influence at this time of year, and that usually appears later in the calendar year. But what's notable is the ocean temperatures still remain warmer than average around tropical Australia, and that could contribute to the wetter outlook as a result of La Nina, but also contribute to those warmer than average temperatures in especially overnight. The left-hand panel at the bottom there shows the modelling for the period from May to July in 2022, and you can see the pink colours around northern Australia showing above average sea surface temperatures generally around the continent. What's also notable in this image is the amount of red and pink showing right around the globe, which indicates that seas have warmed considerably compared with the base period, which in this case is 1981 to 2018. So since that period, sea surface temperatures have warmed considerably, and this signal is expected to get more significant as we go into the future, with a roll-on effect of more high-intensity rainfall events as we go forward. If we look at the seasonal outlooks for the May to July period, so towards the end of the wet season and then moving into the early part of the dry season in the tropics, you can see those red shades on the left-hand two charts indicate well above median temperatures, maximum and minimum, are predicted for the coming season, and a signal of above median rainfall across much of the Australian continent. That's indicated by those green and blue shades there. And I just wanted to point out a new product which has been released by the Bureau of Meteorology, and this relates to forecasting climate extremes in different periods. So we have a range of charts and products which are just shown in this snapshot here. And the way you can get to those is by looking at www.biomedic.au/climate/outlooks. And I'll just show you an example of that new product for the upcoming March to May period. And what it shows you is the chance of unusually wet conditions over the period of interest. And to show a colour shade in here, it has to have a significant chance of being in the top 20% of the historical range. So in this case, we're seeing some green shades around northwestern top end areas of the NT, plus much of Cape York Peninsula in Queensland, less so in the Kimberley. And that suggests that unusually wet conditions in the top 20% of the historical range are more likely than not in the period from March to May. And if we dig down, we'll see that that signal is mainly contributed to by higher rainfall predicted in the March to April period, but less so in May. And I just want to show a couple of more maps. Sorry about all these charts, but they do tell a story. And in this case, we're looking at actual conditions averaged over 7 years for dry seasons following on from a La Nina year. So that's the situation we find ourselves in. The La Nina influence was significant in the wet season. What's going to happen in April and the following dry season? And what you can see here are green and blue shades over Cape York, Kimberley, and top end for rainfall. That suggests that rainfall is likely to be, or has been, in the decile ranges from 5 to 7, just a bit above average during recent years following on from La Nina. And maximum temperature has been quite a bit below average, so deciles 3 and 4, which is much below average of much of Queensland and Central Australia during the years following a La Nina in April. If we look for the entire wet season, for the period from May to September, in past years you can see that the dry seasons following on from a La Nina wet season have been drier than average, and that's shown in the left-hand panel here, where those shades of yellow and pink suggest decile 3 and 4 rainfalls, so below average rainfalls from May to September, and maximum temperatures well above average in southern Australia, but near average in northern Australia. So this sort of supports the sort of, I suppose, the collective experience of people who say that following a good wet season with La Nina influence, you often get a much drier and cooler dry season following that. So that's the case when we average out the previous 7 events where dry season has followed on from a moderate to strong La Nina. And I just wanted to finish by pointing out the introduction of the new Australian fire danger rating system. This is anticipated to come on stream in September of 2022. And the Bureau of Meteorology will be offering new products based on that system, which will replace the existing fire danger and fire danger rating system, but it will also have a similar format to current products. So for example, this is a tabular format for different fire areas in the NT, and on the left is the current system, and on the right is a draft product which will come out of AFDRS, and they were the forecasts for Monday the 14th of this week. So you can see that we're replicating the current system, but also extending it in many ways, and I won't go into detail about that, but also available for fire agencies for their planning is a fire danger viewer, which is a graphical output of the different fuel indices and fire danger meteorological variables as well. So on the left-hand side, you can see a graphic which is currently produced, and you can see the information in there is fairly pixelated, but of reasonable detail, color shaded according to the fire danger rating. And the two panels on the right-hand side show an equivalent product for the new AFDRS system. And what stands out here is the much higher resolution of fuel data which goes into the system. And this is as a result of not only satellite monitoring, but also ground observations from the fire agencies. And this will be available to managers in the fire agencies through a new interface called the Fire Danger Viewer. And I hope everyone's getting a chance, these people in the fire agencies, to have a good look at this system and compare with how it's performing compared to the current system. And there's currently a project proceeding in Bushfires NT in the NT here, which is looking at this very issue. So that's all I'll talk about today. So thank you very much for listening, and I'll hand it back to Nova now for the question and answer session.